So the second presentation will be given by Bartosz Szaniecki, who is software developer at Cloudflare. And the presentation will be about why ReAct fails for smaller language models and how to fix it. So Bartosz, stage is yours. And
Right. So hello everyone. Thanks for the introduction. So as you probably heard, I'm a software developer at Cloudflare. I specialize in large scale data systems, APIs, and of course, as you can probably tell, the agentic workflows. So I'm basically neck deep into agentic workflows and RAG solutions for about 2 years now. So I can quite confidently say that I started working on those before they even became so popular, last year especially. And two key points to address before we start. So first of all, I didn't want to introduce too much code on the presentation. I thought that it would be better to just introduce the Jupyter notebook so you could check the code on your own, as it is quite hard to track the code on the keynote. So basically at the end of today's presentation, I'll leave the QR code from which you could download the archive containing the modules I'll be talking about, as well as the Jupyter notebook itself. And I also introduced some brief summaries of what I am talking about during today's presentation, so you could refer to that in the Jupyter notebook. So let us start with the agenda for today. So I'll start with the short introduction to agentic workflows, what they are, etc. So I know that some of you are probably familiar with working with large language models and the RAG techniques or agentic workflow techniques, but just to make sure we're all at the same level so we could understand the improvements, we'll speak about that. We'll go through the common challenges encouraged with ReAct. So the ReAct is obviously the technique for implementing agentic workflow. And then I'll address the challenges to improve how agentic workflows basically work. So I'll focus on smaller language models. I mean, we're talking about like 8 billion parameter Llama 3, for example. So the key challenge is that most out-of-box frameworks for creating agentic workflows like LlamaIndex or LangChains mainly focus on large-scale large language models like GPT-4, etc. So they work just fine using ReAct, but those frameworks struggle with smaller language models that could be hosted locally, and yeah, that's what we'll try to address today. And the other thing I wanted to mention, at Cloudflare we specialize in OpenStack Cloud, so I'll show you the example of the agentic workflow with the access to the vectorized OpenStack knowledge base. That won't make any difference in terms of how agentic workflow would work, but just to make sure that we all understand what is happening here. Right. So basically, what is an agentic workflow? It is the autonomous AI system capable of calling different functions or methods in Python specifically, or to accessing different knowledge bases, databases, etc. So to put it simple, it is basically a large language model capable of accessing external tools and gaining information based on their output. And the core idea is to combining reasoning with tool use in loops. So as you can see here, It could be used for automated knowledge querying, infrastructure orchestration, or as a personal assistant. And that is actually something that is not mentioned really often. So it could be really useful as a local hosted assistant. So 8 billion parameter model can run just fine on your local notebook, for example, and it could be run offline in a other plane or something like this. So I think that those are specifically useful use cases, and it's a shame that they're not addressed. So what is an agent? So I've mentioned that the agentic workflow is a system that combines LLM with the external tools, but actually the agent is a language model with an access to a specific set of tools or to the specific databases, and it's like one level lower than the agentic workflow. So the agentic workflow can be built on top of multiple agents. So for example, if we are trying to build a system, that large scale system to, I don't know, help the users to generate weather forecast, to generate images, etc., etc., it is not the ideal solution to give single agent like multiple different tools from variety of fields. So the single agent in that term may struggle with accessing multiple different tools from multiple different fields. So let's start with the single agent approach. So in that scenario, we only have a single point of contact for the user. The agent is taking reasoning and triggering tools by the framework. It could be, as I said, either LlamaIndex or LangChain. And by the way, they're both open source. So in that specific scenario, we have a single agent, and that is actually the case we are focused on today. So we will not building like a massive scale system with multiple agents and orchestrator, but just to put it simple, we'll use the single agent approach. But of course, we can also build the multi-agent system when we have the main orchestrator as a point of contact for the user. And then we have different agents that do specialize in different fields. For example, the agent 1 may specialize in generating images, agent 2 may specialize in some math calculation, and agent 3 may specialize in, I don't know, code formatting or something like this. So as I said, it is not necessarily the best idea to give single agent and access to multiple different tools, so it won't chain it effectively, especially when using smaller language models. And what is the ReAct in terms of agentic workflows? So that is basically a technique for calling those tools. That is, to put it simple, a format for the large language models to follow, so the system could handle the tool triggering and responses effectively. And that is actually the standard template for the ReAct in both LlamaIndex and LangChain. So we have a chain of thought, then we have an action with a tool name, an action input, then the system returns the tool response as an observation, and then the agent can either trigger another tool or pass the answer to the user. And then the important part is that by default, all those operations are happening underneath. So we're talking about streamed response, and user should only receive chunks after the chain of thought enclosure. So as you can see, it is not that obvious in that part, but chain of thought is basically a block that should be closed by the answer prefix. And the final part that should be actually passed to the user is the part here after the answer prefix. So here we have the real life scenario with a simple agent that is capable of retrieving the weather information. So the user asks model a question, what was the weather like in Warsaw 2 days ago? agent, as of course large language models aren't time aware, model have to gather the time information from the time tool. It gains the information. It should perform the reasoning so that as it got the date, it should trigger the weather tool with the proper date and the appropriate location to get the weather for that specific user query, and then it could answer the user's query. So that is a setup breakdown. As I said, I didn't want to include too much code, so I basically, that is an example taken straight out from LlamaIndex tutorial that could be found in their documentation. So that is a quick code snippet. We're creating a retriever tool that is actually created from the retrieval that targets the vectorized OpenStack knowledge base, as I said. And then we are declaring our large language models. We'll be using our Cloudfero's Sherlock API, and we are using Llama 3.370 billion parameter instruct model for that case. All right, and we're creating the ReAct tool, a ReAct agent with the access to that one specific tool and with that language model. So in the perfect scenario, when receiving a query, can you tell me about OpenStack networking, the ReAct agent should trigger the retriever tool to gain the information about OpenStack networking. It should be passed to the vectorized knowledge base. It should, depending on the configuration, retrieve the specified number of nodes, return that to the ReAct agent, and ReAct agent, based on that information gained from the database, should respond to the user. That is the perfect scenario. Unfortunately, it doesn't work this way. It's not that simple. So that is the observation that is also available in the notebook mentioned at the beginning. You can also run it on your own to see that it's not that simple. So the first issue to address is a slow initial response. So it took even more than 20 seconds to even get the first chunk for the user. And the main issue, as we could see in the logs, was that the model didn't actually understood its purpose. So here's the real log snippet. So we started with simple hello query, and the model actually triggered the retriever tool with the hello input. And in another loop, it triggered the tool with the what can I help the user with. So it took like 5 or 4 loops until it finally closed that reasoning block with the final answer to the user. And it was pricey in terms of tokens, and it made the system feel like unresponsive, because for more than 20 seconds there was no response from an agent. And yeah, that was just a simple hello query. So what we can do about it, a quick and easy fix, is a prompt engineering. Of course, LlamaIndex passes the default ReAct template to the model, so it could follow it. And the model, the template includes the set of instructions for the model to trigger tool and how to talk with the system. But it doesn't actually, of course, include any information of what is the what is the use case of that specific assistant. So we're trying to add system prompt, explaining to the user that it is the assistant with an access to knowledge base containing transcriptions from different OpenStack events, and it should only use the tool if the question is related to OpenStack services. So that is a quick, straightforward solution, but it is more about masking underlying structural issues rather than resolving them. So we come into another problem. I've excluded the thought, a chain of thoughts section from that specific log snippet just to make it shorter, but it is there still. But the issue now is that for the hello, it answers properly. It generates a chain of thought and the answer, hello, I'm your OpenStack assistant today. How can I help you with OpenStack services? But following that with another question, tell me about OpenStack networking, the model answered and then tried to trigger the tool midstream, which is by default not handled by the LlamaIndex agent runner, as it only waits for the action block to be at the beginning of the response. So there's a chain of thoughts with thought prefix, and it can be either enclosed by answer prefix or action prefix. If there is an answer prefix, the generator is passed directly to the top layer of the system, so that action is not really exotic word. It can occur in standard text generation. So to not misunderstand action triggering, everything after the answer prefix is directly passed to the user by default. So in that scenario, the action was printed to the user and it wasn't even triggered. So we didn't get any information about OpenStack networking, and what's more, we could see the actions which we should not be seeing. The other issue occurring is that the small instruction models basically tend to not follow the instructions, and in that specific scenario, it often forgets to close the chain of thought reasoning block. So it forgets that it needs to be enclosed by the answer or the action trigger. And in that specific scenario, it is not parsed properly by the agent runner. Of course, the agent gets the feedback that the structure is incorrect, and it can correct itself in the other iteration, but it both takes a time and utilize tokens, which may be pricey if using the external model API. So, as you can probably see, the examples showed before and those that are actually available in the notebook are occurring for the 70 billion parameter model. So you could only imagine what is happening for the 8 billion parameter models. They're basically unusable with the standard ReAct structure. And believe me, I've tried many times. You can do the best prompt engineering possible, and it may work short term, but it is not the proper solution or properly addressing the issues occurring during the action parsing. So we have 3 issues to address. First of all, the model tends to forget to enclose the reasoning block. The second one is that model triggers actions when they're not needed, tend to do so, especially smaller models, because prompt engineering fixes that for the larger models. And the third one is that the model triggers actions midstream. So that is also something to be addressed. And so to overcome this limitation, I've introduced the simplified structured approach. So first of all, we're getting rid of the chain of thought reasoning section. And I'll come back to that later, because it may seem a bit disturbative. In such scenario, the model would be speaking out loud, planning the action triggers. But from the small survey we did, that actually makes the whole system feels more responsive. So the model could actually get back to the user with the feedback as soon as possible. Basically, it comes to the user with the right straight away answer that I'll need to gain some more information on that. I'll come back to you in a minute. Then it triggers the two, and then it comes back to the user with the output in a single response. So that is as we got rid of the thought reasoning section. We may also eliminate the answer prefix for passing the final response to the user. And that is because as we don't have the chain of thought block anymore. We won't need to enclose that, of course. So that is something I came up with inspired by the recently popular reasoning models like DeepSeek. So those of you who tried DeepSeek using the API or hosted them, the DeepSeek models on your own, probably saw that they're enclosing the chain of thought in XML-like blocks. And I thought maybe try to implement that in the ReAct structure, so that would only be about tuning the parser itself to understand those action triggers. But it, at the first glance, as you can see, we got rid of the answer prefix. We got rid of the chain of thoughts, and now we are just stick to the simplified structure. And as we are considering mid-stream action triggers, everything that is put above such XML-like blocks or below XML-like blocks could directly be passed to the user. So we are no longer dealing with those language-like action triggers, but we're specifically handling the XML-like blocks for both action and input reasoning. Right, so the crucial improvement, as I said, is the mid-stream action triggering. So the idea is, as I said, the model could start generating an answer to the user and then trigger an action midstream, gather the data, and come back to the user in the same message. The challenge is to hide those midstream action triggers during the response. And the other challenge is how to handle those, because the system won't no longer be waiting for that action block to occur at the beginning of the stream, directly after the chain of thought. And that's a small anecdote from me. When we were planning today's session, I was actually using my own custom-made orchestrator to handle such scenario, and it was really complicated, and I was basically messing up with LlamaIndex internal components to make that work, but it was working, and I was actually tending to showcase you that. But just 2 months ago, LlamaIndex introduced the agentic workflow, the agent workflow, actually orchestrator, and it addresses one of the issues. So it is now possible to pass the answer to the action parser after it was fully generated. So from now on, we can wait for the whole answer to be generated by the model, then we pass the answer to the action parser, and then we can retrieve the actions that were occurring midstream or at the beginning or at the end of the stream. As we are using XML-like blocks, it is really simple to basically gather those. But we are still struggling with hiding the XML-like blocks, because the new agent workflow from LlamaIndex actually returns all the chunks for the user. So all the action triggers, all the inputs, etc., are directly passed to the users as chunks. So that is just a short summary of what I was talking about. And yeah, the other key point actually is that XML-based action blocks are less likely to naturally appear in casual model outputs, which is also beneficial, as the actions may now occur anywhere in the output. The action phrase, well, it is quite popular, so it may occur everywhere basically, and putting that in XML-based action blocks, well, makes that actually less likely to naturally occur during response generation by the agent. So, perceived downside, as I said before, model tends to think out loud, so it basically tends to to return the previously internal reasoning to the user. But on the other hand, that means immediate response to the user with the action introduction, etc. So to handle the technical implementation, and that it's also available at the in the notebook, I've created something called the formidable parser, which actually combines the class, the agent parser introduced by LlamaIndex with my custom-made base formatter, so that it could aggregate up to defined by the configuration. By default, it captures 3 recent chunks in the buffer, so there is always 3 chunks delay before the user actually gets the response from the agent. And well, if the action trigger block occurs, it stops returning chunks to the user, but it aggregates its internally, waits for the input block enclosure to occur, and then for the rest of the messages, after the model finished streaming, it passes the whole message to the action parser, which retrieves the XML-like blocks and triggers appropriate actions and return the action output for the user. And as you will see in the notebook, that basically we went from the totally unusable agent system to a system that is using the 8 billion parameter model hosted locally using Ollama, and it is now usable. It's not only usable, but it's worked perfectly. It even can compare with the GPT-4 models combined with the standard structure. So yes, that is the QR code for you to get the zip notebook. After scanning it, it would proceed to downloading the zip file. You may save the link and just access that later. So that will be it from my side.
So thank you for your presentation. Do you have any questions?
Thank you for the presentation. I always have questions. So my question is more general. What do you think about agentic workflows versus predefined workflows? Because especially for smaller language models, maybe we should just abandon agentic workflows and just stick to the predefined steps, predefined usage of tools one by one.
So you mean the function calling, standard function calling?
No, I mean, in agentic frameworks, in agentic flow, we let model to decide what tools the model should use. And in predefined workflow, we can just say, okay, if you get question, always retrieve documents, always check the date, and so on.
I get it. Right, so it would depend. I mean, the agentic workflows are more elastic, so the model can gain more information from the user because it is, yeah, we are talking about cost efficiency. So for example, when we are dealing with some RAG solutions, passing each query to the vectorized database would need translating each query by the embedding model for the embeddings and then comparing the embeddings with the vectorized database. That may be pricey as well, as there is, I mean, embedding models are basically cheap, but comparing each query or translating each query by the embedding model may be a bit costly in large scale and would require us to also either host or use the embedding model by the API. But that is in terms of the RAG solutions, and the other thing to address is, for example, I was working on the local assistant to create Jira tickets from the summary, and that is actually something that could not be done the standard way, because the model needs to get the information from the user. We're talking about human in the loop function calling. So the model comes back with the, for example, the proposed structure, or we may even create a local assistant for sending the emails for our coworkers, and then the model agent actually comes back to us with the proposed email content, and then we may either accept it or deny it, and it is safe to collect within the agent so that the model won't mess anything up with the email content when sending it to the user. So we need to always accept it, and it is kept inside the system.
Thanks for the presentation. I have more of a high-level question and a subjective one about this single point of contact with a user that you mentioned that is shared by all of the all kinds of agentic workflows, so the chat. And this is maybe a little bit from the product perspective, but is it really the right interface for a user? Is it the future, or the agentic workflows, if they are going to solve the problems for us, will be hidden somewhere inside the hood of the applications?
I don't know if I understand the question correctly, because
so like generally, if you build some applications that needs to solve something via an agentic workflow,
right,
is it really the chat that users should interact with?
well, it would depend, because maybe in that specific scenario, it's not the chat interface that should be available for the users, but if we look on that on the larger scale, for example, ChatGPT, as probably many of you use ChatGPT every day, it's an agentic system by itself. So it can it has an access to variety of tools, from generating notebooks, generating images, etc., etc. They're all called by the model, and the idea behind the ReAct technique is to build the ChatGPT-like interface on your own. So you can basically take a plain language model and give it an access to the image generation API or some calculation API, etc., etc. So it is more about. But do you have any specific scenario in mind?
Yeah. The reason that I'm asking is kind of related to what Piotr said. So some predefined workflows, because I'm wondering if the problem that we try to solve here isn't actually the problem that we somehow created ourselves. Basically, like not giving a proper interface to choose particular tools to be triggered by specific actions in the entire project workflow. I mean, it's kind of abstract when I'm talking about it, but I mean, the agentic workflows also try to be like covering a lot of different use cases.
Yeah, that is true. Well, it is. I don't have like the straight answer to your question. Well, it would depend on the use case and the specific scenario. So, for example, there are many agents to help the end users with the usage of a specific products. Well, in such scenario, it would be beneficial to introduce the agentic workflow, so the large language model could gain an access to the external database. So there, of course, there are scenarios that the agentic workflow is not the ideal solution, but for like human-friendly interface, I believe that it is the only thing we have at the moment.
Okay, thanks.
Any more questions? So thank you, Bartosz, again. And
Thanks.